So, 6.4 is our last section, and it's equations involving inverse trig functions, okay? So we're going to be focused on solving for x in terms of y using inverse functions and solving inverse trig equations, okay? If you have a calculator, good. If not, you may want to grab one as we go through and do some calculations. All right. Yes, you need your calculators today. All right, so up first we have, it says y equals 3 cosine 2x for x where is restricted to the interval 0 to pi over 2. So that means we're in what quadrant? 1. We're in quadrant uno. So our x value has to be in quadrant 1. Make sense? Yeah. And we want to know what angle in quadrant 1 would make this true statement. So we're looking at y equals 3 cosine 2x. That's the baseline of it. Then we're going to isolate, try to get x. So you're trying to get x by itself. So we're going to do the most basic thing that we can is move our coefficient. So if I'm multiplying the coefficient, I'm going to divide. So now I'm down to y divided by 3 equals cosine 2x. Okay. Do we remember our double angle properties? Double angle, cosine double angles. And chapter 5. You can always look, but you don't have to. I'll pull it up for you. So for double angle, we would normally split this, but we're not going to have to. We're going to use inverse operations, which means we're going to use arc cosine, or not arc, cosine to the -1. Okay, because our goal is to get what by itself? X. So our goal is to get. Have y'all had a day where it just seems like nothing's going right? That's my day today. Why would we use the double angle? So we would normally use double angle if we had a value, we could keep going and expanding, but it just makes it harder. Now that we have inverse option, we can use our arc cosine or our inverse cosine, right? Remember that arc cosine means that it's cosine to the -1. So just another way of saying. Okay, arc cosine is used typically when they don't want to add like more numbers to a problem. So instead of writing cosine to the -1, they just write arc cos y over 3. Okay, what is the last thing we're going to do to get x by itself? Divide by 2. So we would divide by 2 or multiply by 1/2. So is x now by itself? Yes. So x is now by itself. Is it 1/2 because it's like an invisible? It's 1/2 because when you divide by 2, it's the same thing as multiplying by 1/2. Yeah. And this is where we would stop. So when we look at the graph, this is all we would have to do. This is all they're asking you to do is get x by itself. Because do we know the value of y? No, we can't go any further. We just know that our y value. So looking from 0 to pi over 2, what is your y value? It's your high and low of your y value. There you go. So that would be our high and our low. And that would be where you would stop at. That's all you can handle.
So do you have to start by dividing the 3?
Yes, because your goal is to get x by itself. Just like any other time you're solving an equation, your goal is to get x all by itself. So once x is by itself, you're here, you're done. That's where you stop. Okay. Now, if I don't have any more information, I don't have anything that's set equal to, then I can't do anything else. All right. So now it says we have 2 arc sine x equals pi. Again, what does arc mean? It's the what? Inverse. It's sine to the -1. So remember, this is the same thing as sine -1. Our goal again is to get x by itself. What's going to be the first thing we do? divide by the 2. So we get pi over 2. Okay. Now, when we just had cosine, we did arc sine. What am I going to do to arc sine? What's the opposite of that? But it's just going to be what? Sine. So we're going to take the sine of both sides. So when I take the sine of both sides, I'm left with x equals sine of pi over 2. In this case, is there a value for sine of pi over 2? Yes. What is sine of pi over 2? So my answer is 1. So you see the difference between when I can give a numerical answer and when I can't give a numerical answer. Yes? All right. So examples 1 and example 2 are your baseline. How do we feel about the baseline? Getting x by itself using inverse opposite operations. Okay. If I'm given arc sine or arc any of my traits, I'm going to use their regular sine, cosine, tangent, right? If I'm giving tan, cosine, sine, to cancel them out, I'm going to have to use their inverse, correct? That's why they're inverse operations of one another, okay? You can check and plug it back in if you're not sure. And it'll come out to be like, oh, the answer is pi. Good job. You're a genius. Because you're asking yourself, when does sine equal 1? Well, sine equals 1 at pi over 2. What's 2 times pi over 2? Oh, pi. I did it. I'm a genius. Yes. Okay. The beauty is when you do get a solid number, you can plug in and check yourself, right? It is a self-check situation. Cool. All right. Let's move up a little bit. What happens when you have multiples taking place? We have inverse cosine and we have inverse sine. And we're trying to solve for x. Okay. The first thing you want to do here is acknowledge the inverse of a half. Right? Well, we know what value gives you a half. Let's think about in quadrant 1 alone. When does y equal 1/2? It will be pi over 6, isn't it? It's 30. Yeah. Pi over 6, right? Yeah. So pi over 6, we know that this is going to be 1. So in quadrant 1, sine u of 1/2 is what? Pi over 6. So we're going to substitute that. Why are we not substituting that value in? Okay, I'm not going to do it their way. They're going around the whole mulberry bush. We're going to do it the straightforward way. What is this? This equals what? Pi over 6. So now we have cosine inverse of x equals pi over 6. Does that make sense? Because we know the value of inverse 1/2. Sine inverse 1/2. And what did we just say? When you have the arc of something, how do you cancel that out? The regular cosine. So x is going to equal the cosine of pi over 6.
The pi over 6 part,
Yeah.
like the inverse.
So remember, inverse is asking, this is what 6.1 was about. Your inverse is asking you, for what value will I have, for what angle do I get this value? So this is saying, for what angle does sine equal 1/2?
Okay.
And
So it doesn't matter that it's inverse.
that's what inverse is asking you. Inverse is saying, this is your ratio. What is the angle? So I'm asking you, for what angle will I get a sine of 1/2?
Oh, I see. Okay.
Yes?
Yes.
So like, let's look at it in terms of your calculator. And I'll even put it in degree mode to. Sylvia had to be completely rewoken. So I'm going to go to mode. I'm going to switch to degree so you can see it. Okay. I'm going to do the sine inverse. So second sine of 1/2. And I get what? 30. I get pi over 6, which is 30 degrees, right? So it's telling me that sine inverse of 1/2 is pi over 6.
So we can just plug in if we get confused.
If it's on the calculator side of the test,
Or
yeah,
like in like assignments. or something.
yes. Okay, so that's why that is pi over 6, yes? All right, so then now we're down to cosine inverse of x equals pi over 6. How do you get rid of the cosine? The inverse, you're going to multiply by cosine, right? Because we're doing the opposite of it. So now you're asking, your x is by itself, and you're asking yourself, what is the cosine of pi over 6? So what is the cosine at 30?
Square root of 3/2.
So x equals. So x equals the square root of 3 over 2. That's the most straightforward way. What we're about to see is the textbook way of doing it.
Do it right.
But I want you aware of it. How do we fill out this straightforward? Take the knowledge you know, you plug it in, do the inverse, and there you go. The opposite operation. Doable? Okay. All right. So, textbook, they're going to show you the U method. So with the U method, they're going to substitute in here what this is with a U. They substitute in U, and now they're just saying you're taking cosine inverse of x equals U, which means that you're just going to have cosine of U equals x. Yes? Essentially, is that not what we did? But we, instead of using U, we just found the value, correct? And then they're going to plug it in. So they're now here. And they're going to ask you, what is the cosine here? Well, what is cosine? Cosine is your adjacent over your hypotenuse. What do you get? Oh my gosh, you get square root of 3 over 2.
See, the U thing confuses me.
Okay? It's not necessary unless it's a value that's not on your unit circle. Does that make sense? It's not necessary unless it's a value not on the unit circle. But when it's a value on our unit circle, we can go ahead and simplify before going through this process. Make sense? And did we still get square root of 3 over 2? Yes, because we have big brain knowledge of our unit circle, so we can apply our unit circle knowledge. Okay? All right. Now, this guy's different. This guy's completely different because it has both of your inverses have an x. Do we see that? So both inverses have an x. You have arc sine x minus arc cosine x equals pi over 6. So you're essentially having to find one angle that satisfies both situations. Okay? So the goal here is we're going to isolate one of them. So we're going to get one by itself. I typically like to just stick with getting the one that's moving the negative and making it a positive. So when we do that, we're going to just go ahead and add arc cosine x to the other side. Because if not, then I would have to subtract and then divide, right? I want to just be able to move it one at a time. So now I've isolated inverse of x. Sine inverse of x equals cosine inverse of x plus pi over 6. Yeah? Okay. Now, we're going to take the sine of that whole thing. Because in order to get rid of arc sine, we have to take the sine. Opposite of inverse of the trig is the regular, right? Are you still with me? Okay. In this case, we have to use the U substitution. So we're going to let U just be arc cosine x. That's all together. So U equals your arc cosine x. So everywhere there's arc cosine x, we're gonna replace it with a u. So it's gonna look like this now. Sine of u plus pi over 6. Okay, are y'all still okay? So all we did was make it smaller. And then we're gonna use our sum of sine to separate. So we're gonna use the sum of sine. Going back to chapter 5. So our sine sum identity, it's the sine of the first times the cosine of the second plus the cosine of the first times the sine of the second. Does this ring a bell from chapter 5? If you need it, then I'll just tell you. But for your final, this is something you have to have, well, your little one pager. That one page front, back, and front. All right, so from there, we then are going to evaluate. Well, the cosine of pi over 6 and the sine of pi over 6, we know those values, correct? So we're going to plug in the values that we know. They do it the long way. Oh, all right, we're going to plug in the values. Now I got to write. Why do they do it the long way? I don't know. All right, what is the cosine of pi over 6? So what's the cosine at 30? Square root of 3 over 2 plus, and the sine of pi over 6 is 1/2. So that means you have the square root of 3 over 2 sine u plus cosine plus 1/2 cosine u. As far as our paper goes and our multiple choice, I would just need you to get down to this. Well, I'll plug you back in, but get down. If you can do that, then you're great. Now, what was you? What did you take the place of? Arc cosine, right? So you took the place of arc cosine. When we plug this in, we get x equals square root of 3 over 2 sine of cosine inverse. Was it x? Yeah. Plus 1/2 cosine inverse of x. What is going to happen there with the cosine and cosine? They're going to cancel each other out. So we're going to come down to x equals square root of 3 over 2 sine cosine inverse of x plus 1/2 x. And that's because these two did. And I wouldn't want you to go any further. At this point, you wouldn't need to, in my brain. So we won't have a problem that gets this hard. If you can do examples 1, 2, and 3, that's all I need for you for 6.4. Okay? Are y'all comfortable with 1, 2, and 3?
That's it.